Have you ever wondered what makes something pro? All of these companies using pro for their most expensive things, as if they actually offer any value for real professionals. Well, I think it should offer meaningful improvements over the base model for people who actually use these tools for work and expect appropriate performance from them. With that being said, you all know that I love the RP2040 and the Raspberry Pi Pico. But there are a few things that I never understood that keep driving me crazy about it. The noisy DC to DC converter that they chose for their main power supply. This little fella makes any analog circuit on the rail, or even connected to the RP2040 GPIO, die, and deliver awful performance. Next we have the bad ADC reference voltage. Sure, the ADC is not great, but it shouldn't be capped by the noisy power supply and the lack of any actual reference element. At least the Atmegas found in Arduinos offered a pretty stable internal reference. Also, the use of a micro USB port is very inconvenient. Like, I get that it's cheaper, but it's so much more fragile, and the fact that micro USB is on the way out makes it a bit of a strange choice. There is also the unreasonable difficulty associated with using the non-volatile storage during runtime. And finally, the lack of a reset button.
Why?
And I am not the only one who thinks this way. I have talked to many people who share my displeasure with these aspects of the Pi Pico. But the form factor and the ability to very easily integrate it into your own design is undeniably nice. So on a cold October evening, I set out to make my own Pico board. It should stay cheap and not be too bloated, while remaining compatible with the original Pi Pico in terms of software and footprint. And most importantly, it needs to address the points above. So let's go over the things I changed in the same order as I mentioned them. The DC to DC converter has been replaced with a linear TLV761 or TLV1117, or any other pin-compatible LDO. It has the same output current rating as the DC to DC, provided it is kept sufficiently cool. In case of a non-MLCC stable LDO, a small series resistor must be placed before the output bypass capacitor. With stuff such as the TLV761, a short is placed instead of a resistor there, since those can easily handle MLCCs on the output. Now there is also a proper ADC reference on board, built around the LM4040 3V variant. This reference can be easily enabled or disabled by the end user, with a nice and big solder jumper instead of the 0603 resistor used on the Pi Pico. And obviously the micro USB has been replaced with a Type-C port, including CC resistors, so you can use it with modern C2C cables. A generic I2C flash chip footprint has also been added. The user can even choose to populate something like FRAM in order to treat this as a logging or non-volatile state memory, allowing recovery after power failure. There is also a solder jumper for the write protect pin of the chip, in case you want to log stuff like calibration values or similar. I also tried to preserve the test point locations and connections, but due to the different port and layout, they were slightly shifted. Some functions changed, and I added a new one for the core voltage line, in case you want to do some silly overclocking experiments. And of course, I didn't forget about it, both boot cell and reset buttons, conveniently located far enough apart for you to be able to press one at a time without having to use your nails. And here are the boards brought into reality thanks to PCBWay, who sponsored this batch of test boards and this video, and as expected, they look very good. Same with the other, more complex 4-layer boards for an upcoming project. Now it's time to assemble them and make sure I didn't mess up. After assembling the board with my usual knife tip QFN techniques, I ran a quick test to see if it works by blinking the onboard LEDs, and sure enough that worked. Next I tried overclocking it to 400 MHz and doing some math on the cores. This should stress the core supply decoupling capacitors a bit, and show if I messed that up by placing them a bit further than I ideally should have. But sure enough, it works just fine. That's good. Now time to evaluate the LDO and compare it to the original Pico switcher. This was done by my friend Triple and I, so let's cut to him and see what he's up to.
What I was supposed to do today is take a look at the Raspberry Pi Pico, or well, the new and improved Pro Pico by Dimin. In this short segment, we'll be taking a look at the Pro Pico's biggest feature. Apart from the better silk screen, the ESD port, the non-volatile memory, and an actual reset button and a USB-C port. In this test setup, where one probe with a ground spring is connected to the 3.3 volt regulator output and the other probe to a GPIO pin that provides a trigger source, will be measuring power supply ripple. With no load and the switching regulator on the regular Pico in PFM mode, the ripple is a terrible 100 mV peak to peak. It almost looks like something disgusting scrolling all over the oscilloscope. This noise has a habit of getting into places where you least expect it, which makes sense given the fact that it's spewing garbage all over the spectrum in the name of efficiency. PWM mode is a huge improvement and can be turned on by setting GPIO 23 high. With a 100 ohm load connected to one of the GPIO pins, the ripple with PFM mode improves greatly. Meanwhile, in PFM mode, the difference is hardly visible. Moving on to the Pro Pico, which I had to place a little further away because I don't have an extra long USB-C cable, has an order of magnitude less noise and a much better step response and load regulation with both cores performing floating point operations. The results are more interesting with the 100 ohm load but still much better than the switcher on the regular Pico. So, will I be replacing my Picos with Pro Picos? The answer is a resounding yes, since it is literally just a Pico but Pro. I've reserved this one for a higher purpose.
And finally, to test the EEPROM, I appropriated Cuprums library for these tiny EEPROMs. And sure enough, writing some data to our EEPROM is now easy and can be done without storing functions into RAM and other copium. And with that, I think I'm pretty much done with what I set out to achieve. I'll order a bunch of these and ship them to friends to find and fix any potential issues that aren't obvious from the surface level testing. The project is open source, so you can get yourself some of these boards. You can check out my website for more info, pinouts, and a preview of the board, or go to GitHub and just download the files yourself. Thank you to everyone who helped me with this project. Thank you to PCBWay for sponsoring my projects, and the Raspberry Pi Foundation for making such an awesome chip, the incredible software for it, and an imperfect but still valuable Pico board to support it. Well, this is awkward. The project blew up even before I finished making this video. But oh well, I hope this was still interesting to watch, and maybe it'll blow up even more.